the September 2020 Free State. The sketch shows the graph of a parabola f with the turning point 2 is to 8 and passing through the origin. The straight line g of x is equals to 2x plus 4 passing through a, and p is also shown. 4.1.1 Prove that the equation of f is given by that. 4.1 I am given the coordinates of the turning point of the parabola, and we have this equation minus p squared plus q, where this is the x value of the turning point and that is the y value of the turning point. I'm just going to substitute. Y is equals to a into x. My x there is 2, so when it comes here it's going to be a negative 2 squared plus, that's an 8. They told me that the graph passes through the origin, so I'm going to substitute this point right here, which is a 0 is to a 0. 0, a 0 minus 2 squared plus 8. That's minus 8, and that's going to be a 2, that's a 4, because this is a, then that's going to give me a 4, positive 4. So my value of a is negative 2. Y is equals to negative 2 into x minus 2 squared plus 8 minus 2, and this is going to be x squared minus 4x plus 4 plus 8 minus 2x squared plus 8x minus 8 plus 8 minus 2x squared plus 8x. It's proven. 4.1.2 Determine the coordinates of A and B. At A, that is the point of intersection between G and F. So I'm going to equate the two graphs. 2x plus 4 is equals to negative 2x squared plus 8x. 2x squared, that's a minus 6x plus 4 is equals to 0. And now I'm just going to look for the factors. So this is 2x, x, and that is going to be a 2 and a 2. Minus, minus. 2x minus 2 is equals to 0, or x minus 2 is equals to 0. X is equals to 1, or x is equals to 2. Well, I can see that the coordinates of A, the x value there should be less than 2. So it is x is equals to 1. Then I'm just going to substitute that. 2 into 1 plus 4, which is equals to a 6. So the coordinates of A is 1 is to 6. And then now they are looking for the coordinate of B. When I have a parabola like that, the turning point, it cuts the graph into two equal halves. This half will be equals to the other half. So here I have a 2 and there I have a 0. To move from here to that point, I just need to add 2, because from here to here was 2. So B should be equals to 4 is to 0. 4.1.3 Determine the values of x where f prime of x and then g of x. Okay, f prime of x represents the gradient of the graph of f, and then g of x is just that straight line. So they are telling me that these two should be less or equals to 0. For something to be less than 0, it must be negative. It means that I need to take a positive, multiply it with a negative, or it could be a negative, multiply it with a positive. Okay, so for the first scenario, I'm going to look at where the gradient is positive. Now, the gradient of f is positive on this side, all the way to that turning point. Okay, and where is g negative when the gradient is positive? Well, g is negative from that point going downwards. So I need to find the value of x there. And then g of x is equals to 2x plus 4. And that is an x-intercept, so I'm going to let y equals to 0 plus 4. So x is equals to negative 2. So I'm saying that g of x is negative when the gradient is positive below the x-axis. So it must be x is less than or equals to negative 2. So that is the first scenario. And then now I'm looking for when f at x, the gradient is negative. The gradient is negative from this way. So this is negative. And then the g of x must be positive. So from this point going this way. So the x value there is equals to a 2. So this will be x should be greater than or equals to a 2. Those are my solutions. 4.1.4. Determine the range of f at x plus 1, f of x plus 1 minus 1. My f at x is given by minus 2. So this right here tells me that where I see an x, I must put x plus 1. This is x plus 1 squared plus 8 into x plus 1. And then I need to subtract a 1. Okay. This part right here, it simply moves the graph horizontally. So it's going to move the graph to the left or to the right. But I know that the range is not associated with a horizontal movement, but rather the vertical movement. Currently, the turning point is at what? It is at y is equals to 8. So I'm subtracting a 1 from what I already have. So the turning point, this graph is going to shift to somewhere there, and then it's going to look like that. And then I've moved it 1 unit down. So the y value there should be 7. So the range will simply just be y is less than or equals to 7. That's it. 4.1.5. Calculate the x value where g of x will be a tangent. F of x is equals to minus 2x squared plus 8x. The gradient of g is 2. So I wanna find what the x value is when the gradient is 2. I need to find the derivative of this. Minus 4x plus 8. The gradient will be equals to 2. This is 2 is equals to minus 4x plus 8. This is minus 6 minus 4x. My x value will be 6 divided by 4, which is a 3 over 2. 4.2. I am given that. 4.2.1. Write down the equation of the asymptotes of h. X is equals to 2, and then y is equals to 1. Because this value and that value, they give me the equations of the asymptote. Now I know that this is a fact, so x minus 2 should be equals to 0, so x is equals to a 2. And then 4.2.2. They are saying that determine the equation of the decreasing axis of symmetry. So when the gradient is negative, h of x is given by 2 over x minus 2 plus 1. And then this is h of x minus 1. So where I see an x value, I'm just going to put x minus 1. And then I have that minus 2 there. Plus 1. So this is 2 into x minus 3 plus 1. And then y is equals to minus x plus c. And then I'm just going to take this value and that value and substitute. The y value is a 1 and the x value is a 3, because this is x minus 3, which is equals to 0. So x should be equals to 3 plus c. So c is equals to 4. The equation will be minus x plus